There's a whole lot of new information in Module 25. So we're going to get into more depth about banks and banking regulations, bank reserves, how banks function, and why some of the rules are in place for banks. We'll also talk about money creation. Banks create money when they issue loans. So we're going to get into the money multiplier, a new multiplier that'll show us how far this new money can spread when banks issue loans. And we'll also learn about T accounts. These are accounting charts that focus on assets and liabilities. This isn't quite an economic model, but there have been lots of FRQs on the AP exam about T accounts. So it's definitely something that we're going to learn and practice. In Module 23, we learned about M1 and M2. These are the two main components of the money supply. M1 is the money that's currently circulating. This is money that's being spent in transactions. It's the medium of exchange money. So just to review, M1 includes currency, coins, traveler checks, and checking deposits. These are all either cash or things that are being spent as cash. So the very last one, checking deposits, are often called demand deposits because these are things that households often take money out of on a regular basis. So from the econ perspective, a checking account is the same thing as a demand deposit. And this is where banks get involved in money supply because almost half of all of the money supply gets deposited into banks. When money is deposited into banks, banks can then loan out a percentage of it, which will create more money. Banks are financial intermediaries in the sense that they are an in-between place for people to bring their money where they would like to earn interest on that money. Banks are profit organizations, they are for profit, and when they issue loans, they actually create more money. Now, one thing that's very important to keep straight, the Federal Reserve prints money, but banks create money. There is a difference, and you do need to know the difference. So Federal Reserve prints money, banks create money through loaning out other people's money, in essence. Banks take liquid assets and translate those into illiquid investments in terms of loans for homes and capital equipment. Remember, capital is one of those 4 factors of production. It's about tools and equipment. Savers, when they put money into the bank, are paid interest, and borrowers are charged interest. And there's got to be a difference between the two. So usually savers earn 1% interest or less. Borrowers will definitely pay more than 1%. Usually it's 4% or higher. And then the difference between the two is the profit that the bank earns. So we do need to know who's paying interest and who's being charged interest, who's earning interest, because that will help us know which groups of people like interest rates to be high and which groups like interest rates to be low. The Federal Reserve has some regulatory power over banks, and one of the things they set up is the fractional reserve banking system. That's the concept that Federal Reserve requires banks to hold some money in reserves, and how much they hold is a fraction of the overall deposits. So each type of account has a different reserve requirement. Checkings, savings, certificates of deposit, money markets, any type of account that a bank could offer, there'll be a certain reserve requirement, and that's always a fraction of the overall money that's in those accounts. Bank reserves can be held in one of two places. Banks will hold some of the currency in the vaults at the bank itself. So if you go to the bank and you need to have $1,000 withdrawn, they do have cash on hand, but they don't have all of their reserves at that bank location. A lot of it is held in their account at the Federal Reserve. Banks have vaults at the regional Federal Reserve headquarters, and so there's all of these floors underground within the Federal Reserve where banks hold excess cash. So if they need money overnight, if there was a lot of withdrawals in one day and they're running low on cash, they can get those armored cars sent over and have more reserves to fill in the deficit. So bank reserves, as long as they have the total amount that's not tied up in loans, some of it is in their vaults, some of it is in their accounts at the Federal Reserve. Banks have to keep some money in reserves in case customers want to withdraw money or close out their accounts. They need to have some cash accessible. But on any given day, there will be some customers who need their money, but most of them won't. So they only have a small fraction of reserves in their vault, ergo the fractional reserve system, and they lend out the rest of the money. That's how banks stay in business. They don't make money off of you safely protecting your savings account. They make money off of issuing loans with excess reserves and then charging interest on those things. Now, what gets a little bit more complex is that once loans are made, there's more money in circulation. And this can create money and increase the money supply. So in this picture, we see that if $100 is deposited into a bank, let's say it's deposited into a checking account, and that bank has to keep 10% in reserves. 10% of $100 is $10. That means they have $90 of excess loans that they can loan out. So someone receives that loan, they spend that money gets deposited into the next bank. That bank will have to keep 10% of that money. 10% of $90 is $9, and they have 90% left, $81 that they can loan out. So as you can see, the original $100 has now been loaned out to one person for 90, to one person for 81, and you can see that this keeps going and going and going. There's still money that can be loaned out. So it's not possible for $100 deposit to stretch out into a separate $90 and $81 transaction. Clearly, money is being created. And this is where things are going to get a little bit more complicated in Module 25. One major new concept in this module is T accounts. T accounts are really just charts that show assets and liabilities. As you can see here, the chart, we have one line across and one line down that kind of forms a T. And that's really why it's called a T account. There will be assets always on the left side and liabilities on the right. Assets are things that are worth money. You own assets and they can bring in income and wealth in the future. Liabilities must be paid in the future. You owe this money. So really, assets are money coming in. They are positives. And liabilities are money going out. They are negatives. You can do a T account. This one is for a business. We'll look at them for a bank. You also could do this for an individual. That would be a micro level. So we're not going to do them in class, but you could absolutely do this in your own personal life and see, all right, kind of the pros and cons. This is all the money I have coming in. This is all the money I have going out. So in this case, we have a smoothie making company. And on the asset side, we have they own their building. That's worth $30,000. So that if they ever needed liquidity in the future, they could potentially sell that. It's worth something to them. It's an asset. Also, any machinery, capital equipment that businesses own are assets. So those go on the positive side as well. Now, loans from a business perspective are liabilities. If you take out a loan, you have to pay that back. So that is the negative side, money that will be going out in the future. So if we wanted to see the net worth of this business, you would add up the assets. So 30,000 plus 15,000, we have 45,000. Imagine a dollar sign. I'll just go ahead and then 0, 0, 0 minus the loans from the bank. So we have $45,000 positive minus 20,000, so the net worth would be 25K, $25,000. So this bank, or this business rather, is doing just fine. They have a positive net worth. All you do, add up assets, subtract liabilities. Now we have a T account from a bank's point of view. They still have assets and liabilities. Assets are still on the left, liabilities are still on the right. What's different is what is an asset for one person might be a liability for somebody else. So if you recall, on the business T account, loans were a liability because the business has to pay that loan. Loans are assets to banks because other people, borrowers, have come to the bank, they've taken out these loans, and this is a way for the bank to make money. So they will get paid for loans that they issue, and that's why loans are assets for banks. Reserves are also assets for banks. The idea is people deposit money into the bank, and the bank has to keep some of the money in reserves, but that's value that they have, money that they could use. Deposits, in this case, these could be checking accounts, savings accounts, whatever they are liabilities. Because even though it looks like this bank has $1 million, it's not actually the bank's money. That belongs to the customers of the bank. And if the people come into the bank and they withdraw their money, then the bank has to give it to them. So that's not theirs to keep. So the deposits are liabilities for banks. Loans and reserves are assets. It's all about, am I making money? That's an asset. Or is it costing me money? That's a liability. We have a second T account for a business. This one is a jersey company. They have assets for equipment and cloth on their inventory, but they also owe a loan to the bank. So for the net worth, remember we're going to add up the assets, total the assets, and then subtract the liabilities. So in this case, 50,000 plus 10,000 equals $60,000 in assets minus $25,000 in liabilities will give you a net worth of $35,000. T accounts can also show you what percent of the overall deposits banks are holding in reserves. So in this T account for Main Street Bank, we have $2 million in deposits, but $200,000 in cash reserves. So what percent of its reserves is it holding? $200,000 is 10% of $2 million. So it has 10% in its reserves. We have a simplified T account for a bank, and it's simplified in the sense that there's no dollar amounts attached to any of these things. We're just seeing would each of these categories count as an asset or liability for a bank. So when you're drawing this on your notes, remember assets are always on the left, liabilities are always on the right. And we need to have a title because it's important to differentiate, is this a T account for a bank or for a business? Because sometimes things are assets for one group and liabilities for the other. So the first one, demand deposits. Would that be an asset or a liability for a bank? That is a liability because banks, that's not their money. If anybody comes in and asks for it back, they might have to pay that money back. So that is a liability. So write demand deposits on the liability side. The government bonds are new. We haven't talked about that yet. Banks can own, they can purchase government bonds. When banks have excess reserves, they could use that money to loan out, but they also could use it to buy government bonds. This is another way for banks to earn a profit and stay in business. So because they own these things and these things are worth money to the bank, does that give you a hint about which side it goes on? Government bonds are assets to banks. So we're going to write that on the asset side. Now the other two we've seen before. Loans, from the bank perspective, are a way for banks to make money. So loans are assets, and then reserves banks can use to either purchase bonds or purchase loans. So reserves are assets to banks as well. So go ahead and pause for a moment and write demand deposits as a liability. And then government bonds, loans, and reserves are all assets from the bank perspective. The ratio of reserves to deposits that a bank holds is called the reserve ratio, and this can be either written as a percentage or a decimal. When we ask for the reserve ratio, it will normally be answered as a percent. They're holding 3%, they're holding 10%, they're holding 15%. But when you're doing the math later on for the money multiplier, we're going to convert this reserve ratio into a decimal. The Federal Reserve controls the required reserve ratios. So for every different type of account banks can offer, the Federal Reserve sets minimums of how the smallest amount of reserves that you can keep for that type of account. And banks are required to keep some deposits in reserve in case there's a run on a bank. Now, there's a reading in your textbook. It's a little bottom half of a page about bank runs. We're going to do this in class, but in case you're absent, go back and read it on your own. Bank runs used to be a major issue before FDIC. FDIC, remember, is the Federal Deposit Insurance Corporation. So it used to be that if banks ran out of reserves on hand, people might think that the bank was going to go under, and people would run to the bank and all demand their money. But now we know that even if the bank is short on funds for maybe one day, there were a lot of withdrawals, it would be just fine because they can borrow money from other banks, the FDIC can bail them out, your money is going to be safe. So they do have to keep some on hand in case you want a small or medium-sized withdrawal, but if every single customer went to the bank at once, FDIC would be there to back you up. Like we've stated, bank runs used to be a more serious problem, but they do still exist in very rare cases, and in countries that don't have FDIC, they're still an issue. So depositors put their money in banks for two reasons. You want to earn interest off the money, but you also want to keep the money safe, and people trust the banks more than they trust saving their money under their mattress or putting all of it in your purse. But the issue is, if the public loses that confidence and the trust in the individual bank or in the financial and banking system, that paranoia can lead people to want to withdraw all their money. If some people withdraw their money, it's not a problem. But if every member of the bank goes to the bank to withdraw their money, that's a bank run. And because banks only have a very small percentage of all the deposits in reserve, when people go to the bank because they're afraid of the bank failing, it can create a self-fulfilling prophecy. A self-fulfilling prophecy, a prophecy is a prediction, and a self-fulfilling prophecy means that it's a prediction that makes itself come true. So if everybody thinks the bank is going to fail, so they run to the bank to withdraw their money, that action makes the bank fail. So bank runs can lead to bank failures when the bank is unable to pay back every depositor in full. If you could only receive 20% back from the bank because they didn't have all of your money there, that can create a crisis of confidence and can lead to bank failure. Now, the reason why a lot of your money isn't there, as you know, is that most of the excess reserves held by the bank are in loans, which are illiquid. Banks can sell loans to other banks. But there's a difference between regular transactions and selling loans bank to bank and one bank trying to sell off all of their loans. Because if one bank is trying to sell off all of their loans, other banks can look at that bank with caution. And they're going to wonder, why are you selling all of your loans? What's wrong with all of these things? And so the bulk sale of all of these loans can actually lead to a decrease in the price or the value of the loans. Because if nobody wants to buy them, the banks are going to have to lower the price to entice someone to buy it. So even if they sell off all of their loans to get liquidity to pay back the depositors, they might have to sell off some of them at a discount to get money quickly. And so if they don't have all of the cash back to pay all of their depositors, that could become a bank failure. It's true that in modern times, the FDIC would pay back those depositors, but the bank failure would still exist. That bank would go out of business. What's interesting is that bank runs can actually become contagious, because if rumors are spreading around town about this individual bank doesn't have any of our money, that can lead people to think, well, wait a minute, well, is my bank safe? Because in reality, banks are really interconnected to other banks. If they have sold loans to other banks, people might think, well, wait a minute, if this bank owes my bank money, is my bank going to fail? And all you need is fear. And when fear spreads, people start going to all of their banks. And even if their bank wasn't experiencing any sort of crises, if people all go to the bank in a panic, it can lead to a bank run at that bank, and that can spread to another bank. So bank runs can go across a community and become a major problem. And this is a reason why the Federal Reserve was started, to try to regulate banks and to try to safeguard the community so people had more faith in their banks. We've discussed the issue of bank runs. There were a lot of bank runs in the 1930s during the Great Depression, and people started to really not trust banks. For that reason, we set into place many regulations to make sure that the public felt comfortable saving their money in banks. And when people feel confident in the banking system, it greatly reduces the likelihood of bank failures. Since the most recent Great Recession, we've also had a lot more bank regulations. So during the Great Recession, the government actually bailed out many banks that were considered, quote, too big to fail. This concept is that we had many very large banks that had done very risky loans. So when they started to fail, instead of creating a bank failure and going out of business, the government decided that some of these corporations are too big to fail. It would be too big of a hit on jobs, on the local and federal or national economies, in order to let them go out of business. So Dodd-Frank Act was an act within Congress named after two of the main founders. And that actually subjects all banks that are very, very large. If you have $50 billion in assets or more, those banks have to go through additional supervision and regulation. So if you're a small credit union, a family-owned bank, something like that, then you go through the normal regulations. But these major nationwide corporations, we wanted to make sure that we're not going to have a too big to fail situation again. Moral of the story, as our economy gets more complex, we actually continue to make more bank regulations to stay in touch with the current issues going on in banks, to make sure that money is safe in banks, and that the public trusts the banks. So here are four major categories of bank regulations. Some of these are here also to safeguard the public into feeling like their money is safe in banks. The first one is deposit insurance. This guarantees bank accounts up to $250,000. The next one is capital requirements. Banks are now required to keep some of their money in capital investments, things other than loans. So we'll get into some examples of that. It's a way to diversify. The third regulation is reserve requirements. We've talked about this quite a bit already. The Federal Reserve requires banks to keep a certain percentage fractional amounts of each of their deposits and reserves. And then another new one we're going to talk about is the discount window. And this is the idea that if banks need a short-term loan because they're low on cash and a lot of people have done withdrawals, they can actually get a loan from the Federal Reserve, just temporary, but it keeps liquidity, it keeps money in banks when they need it. So if customers come to the banks, they always can get their needs met. The banks have what they require. This one we know, deposit insurance. FDIC is the Federal Deposit Insurance Corporation. This is a federal agency that makes sure that deposits within bank accounts up to $250,000 are guaranteed by the federal government. So if the bank fails, your money is protected. And because borrowers in America know that this exists, it reduces the amount of bank runs we've had. Because no one is really afraid of their banks failing, this confidence actually slows down bank runs. You might have heard on the radio, for sometimes when they're advertising a bank, they'll say at the end, FDIC insured. Listen for it now if you haven't heard it in the past. When FDIC was created, the amount of money that they insured was actually lower. And it's possible that they might increase their minimum at a later date. Maybe as we go through inflation, this could go up. But in the meantime, the fact that it's there and that money is insured up to a pretty high dollar amount makes confidence in banks much higher. One interesting side effect of FDIC is if you know that no matter what your bank does, even if they go out of business, your money is safe. What incentive is there for banks to play it safe, for banks to be smart, and to only issue loans that have a chance of getting paid back? The Federal Reserve and bank regulators realized that banks could certainly become risky if there aren't safeguards in play. People with bad credit are charged higher interest. So even if a lot of those people default on their loans and they stop paying them back, while they were making payments, banks are making higher interest than they would if they only gave safe loans to people with excellent credit. And depositors, people who are customers of banks, would have no real incentive to watch their banks closely, to read articles about their banks, because FDIC backs them up. What do I care if my bank is a little bit shady in their business practices? So to reduce the incentive for risky lending, bank regulators make sure that banks don't just use excess reserves to issue loans. They have to use some of this money and a lot of their assets in order to finance safe things called capital investments. So the idea is banks' capital, it's kind of like their net worth, their assets minus their liabilities. And they want to make sure that banks have capital investments in things that aren't going to default. So banks can put some of their excess reserves into government bonds. Those are guaranteed. They're certainly safe. And banks often choose to use some of their money to advertise, to sponsor scholarships, or sponsor sporting events and things that get publicity out, but also a way for banks to get liquidity quickly instead of tying all their money up into risky loans. So this is kind of forced diversification. Banks have to use some of their assets into safe investments. That's these capital requirements. Here we have some images of various events. A lot of these are sporting events that are sponsored by banks. It's a way for them to have capital investments tied up in things that aren't going to default. So you can see we have some biking competitions, football, golf, racing, all different ways to diversify their assets. and get some publicity while they're at it. The third bank regulation are reserve requirements. So we know that the Federal Reserve wants to make sure that banks don't loan out every single dime. Banks would love to do that if they could. They would make the most profit possible. But the Federal Reserve wants to make sure that there's some cash on hand for withdrawals. So each type of bank account has a different reserve requirement. Demand deposits have a reserve requirement of 10%. And remember, demand deposits are the economic way of wording a checking account. Your checking account is the most liquid type of bank account because people use their checking account like it's cash. We don't have as many restrictions on how many transactions you can make in a month. You can go down to 50 cents in your checking account and there's no penalty, right? You haven't gone under. So for that reason, there's a fairly high reserve ratio of 10% for those. Accounts that people don't withdraw from as often, like savings accounts, are lower. Certificates of deposit, where that money is locked away for a few months, have an even lower reserve requirement. So each account has a different number. You do need to know that 10% is required for demand deposits. Excess reserves are the 90%, all of the extra reserves that aren't being held. Can be used by banks either to issue loans or to buy government bonds. So government bonds are something we're going to learn about a lot more with monetary policy. But both of these things are ways for banks to earn interest and for banks to earn a profit. So they have to keep some reserves in this requirement locked away, and the rest of the reserves they can use for loans or bonds. We are talking about bank runs and how in desperate times, if banks need liquidity right now, they can sell off their loans to other banks. But if they try to sell off all their banks at once, that might lower the price of those loans. It might hurt them. So another bank regulation is really kind of a safeguard for the public, and it helps banks too. The discount window is a last-minute option. The Federal Reserve does not want to loan banks money. It's actually a nickname for the Fed. It's called the lender of last resort. They will loan banks money, but they don't want to. They would much rather banks borrow money from other banks, especially other banks within their same chain. You know, Bank of America can borrow money from another Bank of America. They'd rather that banks kind of handle it within themselves. But let's say there's a major economic problem and a lot of banks are low on excess reserves and no bank can loan another bank money. Banks are feeling desperate. They might have to sell off their loans. Well, we don't want that to happen. So the Federal Reserve has this last-minute option called the discount window. And that's the idea that in an extreme kind of last case, if banks need liquidity, they can borrow money from the Federal Reserve. So discount window is a loan between the bank and the Federal Reserve. The interest rate that the Federal Reserve charges banks is called the discount rate. And one of the tools of monetary policy that we're going to learn later on this unit is adjusting this interest rate. If the Federal Reserve wants to discourage banks from borrowing money from them, they can raise the discount rate. If they want to encourage banks, go ahead, be a little riskier, issue some more loans, let's get this economy going, they might lower this discount rate to encourage banks to do so. Either way, this discount rate loans are short term. Often they're only 24-hour loans. So if you've had a withdrawal and a ton of people have come in to take out money, you can borrow money for a 24-hour window, pay the discount rate, and stay functioning. So the next part we're going to get into is about how banks can create money and how banks do have some effect on the money supply. Remember, the Federal Reserve prints money, but banks can create money. So one way that banks can have an impact on the money supply is by removing currency from circulation. So they do have a little bit of power to, if they're going to keep more money in reserves than they have to, then there's less money circulating. More of it would just be sitting into accounts, in their bank accounts. The other way that banks would have power is to make loans. We've hinted at this, the idea that when a loan is issued, that's creating money, because that original deposit still belongs to the depositor, but the bank is using that money to loan to someone else. So that new money doesn't belong to them, but we start to multiply, which will expand the money supply. And we're going to go through all of the steps of that process. So a lot of the rest of the notes are actually focusing on number 2, banks creating money through the act of issuing loans. The first step to the multiplication of money when banks create money is to really be clear on what excess reserves are. So reserve requirements are set by the Federal Reserve. And so the total reserves are the amount of money the bank is holding. And you can subtract to the required reserves the amount that they have to hold. Whatever's left over is excess reserves. The excess reserves are what we're going to use to lend out. So oftentimes when there's an original deposit, all of that money goes into reserves originally, so that would be 100%. If 10% of those are being held in required reserves, then you would have 90% left in excess reserves. But it's possible that maybe you loaned out some of that money. So $1,000 were deposited. We already loaned out 500, so now we have maybe 40% reserves left, minus 10%, and then our excess would be 30. So all you're doing is looking at how much do we have in reserves, how much are we required to have. The difference is the amount of excess reserves, and we can use that either to loan out money or to buy government bonds. This starts out simply. A loan is given, the money from that loan is spent, and the company or person that receives that money deposits it into their bank. That bank is required to reserve 10% of it. They would loan out the remaining 90%. Whoever receives that money spends it. It gets deposited into the next bank, and 90% of that money is loaned out. So we can see how we have a multiplier of money, multiple rounds of spending. The money continues to grow, but it's getting a little bit smaller each time because it's 90%, then 90% of that, then 90% of that. It's dwindling as it goes. Now, to be clear, in reality, it is quite possible that if I had a loan for $5,000, I might not spend all $5,000. And whoever receives the $5,000 from me might not deposit all of it into the bank. They might keep some of it in their wallet. So you can see how in the real world, it won't quite be that simple of 90% being loaned out at every single round. But we're looking at this in terms of the maximum potential. If all of the money is loaned out, if all of that loan is spent, and if all of that money is redeposited into a bank, then in the maximum best case scenario, how far can that money go? That's what we're going to be looking at. We're going back to T accounts to see all the different stages of how banks create money. So here we have round 1. In this case, a depositor named Silas decided to open up a new bank account at Bank A, and he will deposit $1,000 into this account. Now, in this case, this T account is for Bank A. It is really important to label who the T account belongs to. Because, for example, in this case, it says demand deposits $1,000. Remember, demand deposits are checking accounts. And from the bank's perspective, that's a liability. Because if Silas came in and wanted the money back, they'd have to give it to them. If we were drawing this T account for Silas, that same category, demand deposits, would be an asset. If he has $1,000 in the bank, that's his, it's worth money. So really important, always label the T account. All right, so you're drawing this in your notes. In round one, the bank receives the deposit. So we have the title, Bank A, we have assets and liabilities, we have the categories and the dollar amounts. So even though liabilities, before we mentioned how assets usually are positives and liabilities are negative, well, these things can go up and down. The value of your assets can go down. The value of your liabilities can go up. So we still want to have pluses and minuses within to show a change. Because this bank had other people's deposits before Silas, right? We're not saying that the bank only has $1,000. We're saying that when he put money in, the total amount of deposits the bank received went up $1,000 plus $1,000. So we need the category, the dollar sign, and then a positive or a negative. Now, they don't immediately have somebody to lend the money to. So all of the money that he put into his bank accounts go directly into reserves. So the amount of reserves the bank has gone up $1,000. Now the question tells us that the bank's reserve requirement is 10%. 10% of $1,000 is $100. So I have in parentheses here the required reserves and the excess reserves because they're really just part of reserves. But we need to know how much money can the bank loan out. That's why we're breaking it down. So of the $1,000 in reserves, $100 is required, which means $900 is excess. So the amount of excess reserves they have went up $900. Loans are also assets for the bank because they can use those things to make money, but they haven't loaned out his money yet. So in round one, loans haven't changed. If you need more time to set up the T account for round one, go ahead and pause here. We have the same T account at the bottom, but I just wanted to point out that in the initial round, that original $1,000 is both an asset and a liability for the bank. It's an asset because the bank can use a lot of that money to loan out. 90% of it they're able to loan out. It's a liability for the bank because at any time the depositor can come in and request that money. So because money could leave within that category, it's a liability as well. For the record, from the perspective of an individual, the amount of money that you have in the bank is always an asset. In round two, Bank A is going to use the excess reserves from Silas's deposit in order to create a loan. So Silas gave the bank, he deposited $1,000. So in our T account, the demand deposits have not changed. His $1,000 is still there. So that variable is the same. The bank has to keep 10% or $100 of his deposit in reserve, which means they're able to loan out up to $900. And they're going to loan $900 to Mary. So the amount of reserves the bank has decreased $900 because that $900 has left their reserves. They're no longer there, but their amount of loans has increased $900 because now they've issued this loan to Mary. Remember, it's always important to label the T account. Silas's T account wouldn't look any different at all in round two. Nothing has changed for him. If this was Mary, now all of a sudden, if we're drawing a T account for her, which side would the loan go on for Mary? There's a loan, an asset, or a liability. For her, the loan is a liability because she has to pay that back. So if we were drawing one for Mary, it would say loans plus $900 on the liability side. So always, always label your T accounts. Pause if you need more time to fill this one in. In round three, Mary spends the $900 that she received as a loan at a store. That store has a bank account with Bank B. So we have a new bank that is now involved. So when the store that receives her money deposits their earnings for the day, that means that the amount of demand deposits at Bank B have gone up $900. Now, it is too soon for that bank to loan it out. If you deposit your money, there's not a line of people waiting at the bank right now to get that loan. So, in the immediate impact, the reserves of Bank B go up the same dollar amount as the demand deposits. Now, we're going to assume that this is in a checking account because it says demand deposit, so it's still a 10% reserve requirement. 10% of $900 is $90. So the required reserves go up $90. 900 minus 90 equals 810. So the amount of excess reserves that this bank has is 810. So would the lending and money creation stop there? No. Bank B can loan out $810. And then you can imagine that money can get spent and redeposited, and that bank can loan out 90%, and it keeps going. But I wanted you to see how we set up T accounts, because this process of where the assets and liabilities are affected and how this is all labeled will need to be done. So you'll need to be able to set up these T accounts on your own. So the original $1,000 deposit led to a $900 loan. And that new money, that new $900, impacts the money supply because that money is now circulating, even though it's not real money. M1, remember this is the money in circulation, gained $900 because Silas was just saving money. Saving is M2, and it's going to switch over to M1 and start to circulate. So Silas still owns $1,000 in the bank, but Mary now has $900 in cash as well. And then whoever receives that new loan, if Bank B issued a loan for $810, then that money would start to multiply as well. So we're seeing how money is created through the act of loans, and next part is figuring out the equation to show us how far will it go. The money multiplier is going to be a new multiplier in macro, and this is going to show us how much money will be created for every $1 of excess reserves a bank has. So we're going to need the reserve requirement and how much money in excess reserves banks have available, and then we can see how far this money can multiply. We know at this point that banks issue loans from their excess reserves, and when the loans get spent, that dollar amount gets redeposited into any bank. It could be another bank. That bank can issue more loans with their excess reserves, and this continues on. So the key idea is that money supply increases when new money is created, and new money is created when banks issue loans. So there are a few equations that we're going to need in order to figure out the maximum money multiplier. First of all, we know that the reserve ratio can be converted into a decimal. So 10% as a decimal would be 0.1. 25% as a decimal would be 0.25. So we have to convert this percentage into a decimal for all of these equations. Now the money multiplier by itself is 1 divided by RR. If you remember, we have tax multipliers and spending multipliers in the past. And in that case, we had one part that was the multiplier, and then we multiplied it by something. So here we have the multiplier in isolation, 1 divided by RR. And there's two different total effects that we can learn from this. The first one is how much will this matter in terms of new deposit in banks? So if we want to see how far will this money go within the banking system, you would do the money multiplier, 1 divided by RR, times the change in demand deposits. So let's say there was a $1,000 demand deposit originally, and that the reserve requirement is 10%. Well, we know that 1 divided by 0.1 equals 10. So in all of these cases, the multiplier will be 10. Now what's different is how we use these equations. So to figure out the total change in demand deposits, it will be 10 times the original change in demand deposits, $1,000. So 10 times $1,000 equals $10,000. So that's how much it's going to impact the total deposits in banks. Now, if we want to see how much this will impact the money supply, we're doing the multiplier times the excess reserves. Well, of $1,000, if 10% is reserved, how much will be excess? $900. So the total change in money supply is 10 times 900, which is $9,000. So in both cases, the money will multiply, but the change in the money supply is going to be smaller than the change in new deposits because this original $1,000 isn't circulating. It's still in the bank. So we'll see that effect in the deposits, but in terms of money supply, that $1,000 that's originally invested is still tied up in the bank. It's not circulating. So that's why the money supply is smaller. We're going to do one practice problem together as a class, or together on this video, and then you'll do the chart on your own once you've practiced these equations. Let's look at this practice problem together. So assume Sally receives $500 as a graduation gift. She deposits that $500 into her bank as a demand deposit. Based on this deposit, how much money did the money supply immediately change? And what is the maximum possible change in the money supply if the reserve requirement is 20%? So, if you need a calculator for this, that's okay. Some parts of it you shouldn't, but for the sake of the first practice, if you need one, go ahead. So, what is the immediate change on the money supply? Has anything happened when she deposits the money into the bank? No, nothing. If the money is going into the bank, it's leaving circulation. And so in that case, there's no change until the money gets loaned out. And it hasn't been loaned out yet. So in this question, what's the money multiplier? Remember that equation is 1 divided by the reserve requirement as a decimal. So 1 divided by 0.2 would give us 5. So our money multiplier is 5. The next question is, from that $500, how much of it is required? So what is 20% of 500? It's $100. So that is the amount of money that banks are required to keep. From that, if we know that 500 is deposited and 100 is required, how much is left for excess reserves? $400. That one's easier once you get the required reserves figured out. Okay, now we have 2 more equations. The change in new demand deposits. Remember, this one is the money multiplier equation times the original deposit. So, in this case, our money multiplier is 5. And we're multiplying that times the original deposit, $500. So the total effect is $2,500. For the change in money supply, that equation is the money multiplier, 5, but it's not times the deposit, it's times the excess reserves. So 5 times $400 will give us $2,000. And again, we can see that the difference between the new demand deposits created and the money supply is $500. It's the same as the size of the deposit because that deposit is still in the bank. It's not circulating, therefore it doesn't affect the money supply. That's why the total effect of the money supply is always smaller. you have these practice problems in your notes. So we have some different situations. In this case, the amount of money deposited is $3,000. And that's the only thing that stays constant throughout these questions. Go ahead and grab a calculator if you need one and don't have one already. And you can either go with me and check over number 1 and then do the other 2 on your own, or pause now, try all of them on your own, whatever you feel like you're comfortable with. I'm going to start by going over the first question. So in the first row, we have a reserve requirement of 10%. So in that case, the money multiplier, 1 divided by 0.1, would be 10. The required reserves, so if of $3,000, if we have to keep 10% of $3,000, 10% is $300. And don't forget things like dollar signs, they're very important. So if $3,000 is deposited and $300 is required, you can take $3,000 minus $300 and our excess reserves are $2,700. And then the change in new demand deposits, that's our multiplier, 10, times the original demand deposit. 10 times $3,000 equals $30,000. Change in money supply equation is the multiplier, 10, times the excess reserves. So 10 times 2,700 equals $27,000. So hopefully you now feel comfortable. Go ahead and do the next one on your own. Pause this, and then we can check over the answers. All right, so if the reserve requirement is 20%, 1 divided by 0.2 equals 5. 20% of $3,000 is $600. If we are required to keep $600, 3,000 minus 600 equals $2,400 in excess reserves. For our change in new demand deposits, 5, the multiplier, times 3,000, the original deposit, equals $15,000. And for the change in money supply, 5, the multiplier, times the excess reserves of 2,400 equals $12,000. Again, go ahead and do the third row on your own, and then we'll check. Okay, reserve requirement is 25%. 1 divided by 2.25, the money multiplier would be 4. 25% of $3,000 is $750. That's how much is kept in required reserve. $3,000 minus $750 equals $2,250. Change in demand deposits, 4 times $3,000 equals $12,000. And change in money supply, 4 times excess reserves, $2,250 equals $9,000. So, in each of those cases, we practice the equations. It's also important to see that money supply will always multiply a little bit less than demand deposits because that original deposit is in demand deposits, but it's not circulating for money supply. And finally, as reserve requirements get bigger, as the bank is required to keep more money, you can see that the total effects on the economy get smaller. And that makes perfect sense. Money can't multiply as far if less of it is available to be loaned out. We keep talking about it, but let's go ahead and put it in the notes. The change in money supply total effect has a smaller multiplier effect than the effect on new demand deposits because the original demand deposit is not circulating. It's still in the bank. So you'll see that in the new demand deposit total, but you won't see it in the money supply total. So the difference between the two, money supply is always smaller, and the difference is always the size of the original deposit. The equations that we have been practicing, the money multiplier, the effect on new deposits, and the effect on money supply, all of those are assuming the maximum money multiplier effect. And so there's certain things that have to be true for this assumption to be true. First of all the money that has been loaned out has to be redeposited. There's something, it can have two terms. So you can call it a currency drain or a leakage. And either way, this is actually a common problem. It's the idea that a lot of times people don't deposit all their money into the bank. If you take out a loan for $5,000, maybe you'll keep $100 on hand for an emergency. Maybe the recipient of that $5,000 loan, the company, won't deposit all of it into the bank. Maybe they'll keep some of it in their cash register to give change to customers. Maybe they will pay some of it to their employees in bonuses. Either way, all of that money isn't going back into the bank. And in order for there to be the maximum multiplier effect, all the money loaned out has to be redeposited. We can't have any leakages or any currency drains where money is kept out of the banking system. The second assumption is that all of that money that's deposited, all of the excess reserves have to be loaned out. If a bank has 90% available and somebody only comes in, so let's say I have $4,000 I could loan out, and somebody only needs a loan for $3,200. Banks are going to issue that loan, but you can see how that isn't using every single dime of excess reserves. For the maximum multiplier, all of the excess reserves must be loaned out for this to be true. The assumptions work for a simplified model, but in reality, they aren't true. Money does not multiply as far as the maximum money multiplier would imply, because we do have currency drains and leakages, people holding on to cash and not putting all of it back into the bank. We do have banks all the time that don't lend out all of their excess reserves. Maybe they can't find qualified candidates that need the amount of money that they have available to lend out. So, according to the money multiplier equation, for every $1 spent with a 10% reserve requirement, the multiplying effect should be 1 divided by 0.1, which is 10. So theoretically, the maximum multiplier effect should be 10. But in reality, the money multiplier is more like 1.9, because a lot of people don't deposit all their money back into the bank. It's very foolish to take out a loan and not spend all of the money. Why would you do that? If you're paying interest on a loan for $3,000 and you only needed $2,000, then you have just wasted interest payments. You should take out a loan for the amount that you need and nothing more. So that kind of leakage is just kind of foolishness on the part of the borrower. It doesn't happen that often. But there's a lot of leakages and currency drains in the side of the people that receive the money not depositing all of it. We also have lots of instances, especially during new bank regulations, where after the Great Recession, it became much harder for banks to give out loans. They were really afraid of people defaulting on their loans. And so instead of lending out 90% of excess reserves, they lent out a much smaller percent of the reserves that they had available, which is going to make this overall money multiplier smaller. Another thing to understand about the reality of monetary policy and money creation is that we like to think that the Federal Reserve completely controls all aspects of money in America, but that's not true. The Federal Reserve controls the monetary base. That's a combination of all of the currency in circulation, the dollar bills and the coins that the Federal Reserve printed, as well as the bank reserves, because the Federal Reserve can control the reserve requirements. So if they wanted more money, they can print more money. If they wanted more bank reserves, they could increase the reserve requirement. So they have power over the monetary base. Money can switch from being in circulation to being saved within a bank, so in that case from M1 to M2, but the total monetary base hasn't changed. So because the Federal Reserve controls the monetary base, they control the two left sides here of this Venn diagram, bank reserves and currency in circulation. We've said that the Federal Reserve controls the money supply, and they do up to a point. This part of money supply, the currency in circulation, is controlled by the Federal Reserve. But the Federal Reserve does not control how much money people decide to save in their bank accounts, in their checking account. They can tell banks what percent of that money to hold in reserves, but they can't make you save more or less money in your checking accounts. Individual households and businesses have their own discretion over how much money they want to save in the bank, and that's a part of money supply that is not in the hands of Federal Reserve.